So today we are going to learn about choosing the best model for two variable data. It's our chapter 11, last section, which is section 5, page 775 to 779. Our lesson targets: I can use a graphing calculator to find a model equation for a given set of data. So, choosing the best model. The following functions have been used to model a set of data. To determine the best model for a set of data points x and y, make a scatter plot of the data and choose the type of function suggested by the pattern of the data points. So the different regression models. Our first regression model is linear, and the general form for it is y equal ax plus b. And this is the graph for it. So please write these down in your notebook because they are very important, because you need to know the difference between the functions. So this is the first function, linear, y equal ax plus b, and that is the graph and how it looks like. This is another graph to show the linear function. Second function is a quadratic, and the general form for it is y equal ax squared plus bx plus c. And this is the graph for it. It looks like concave up or concave down graph. So please write this down in your notebook again. The third type is cubic, and the general form is y equal ax cubed plus bx squared plus cx plus d. And cubic looks like this graph as shown. The last regression model is exponential, and exponential is y equal a times b to the power x, and the graph looks like that. It increases slowly or it decreases slowly. Now, example number 1, use a linear model. Tuition example: the table shows the average tuition y in dollars for a private 4-year college in the United States from 1995 to 2002, where x is the number of years since 1995. Use a graphing calculator to find a model for the data. So we have x values and y values as shown in the example, from 0 to 7 and from 14,000 to 21,000. So the first step, what we have to do is make a scatter plot. The points lie approximately on a line. This suggests a linear model. So what you have to do first is go to stats and then click number 1, edit, then enter your values, your x values under L1 column and your y values under L2 column. Then you click second quit and you click in second stats plot and you turn on your stats plot button, and then you go to window and you fix your window. So the x minimum in this case is, the x minimum should be 0, and the x maximum should be 10 because it's close to 7, so it's 10. The y minimum should be around 14,000 and the y maximum should be around 22,000. And you just hit a graph, and if you hit a graph, your scatter plot will show like a straight line that goes up, like what I'm showing you right now in the slide. So the points lie approximately on a line. This suggests a linear model. So this is a linear function or a linear model. So step 2, use the linear regression feature to find an equation of the model. So use the linear regression feature to choose the linear function. So if you click on the linear regression feature, you will see 4 different types: exponential, linear, cubic, quadratic. You need to choose the linear because the scatter plot gave us a graph that is linear. So you click enter, you choose linear regression, you click enter, and you get the y equal ax plus b, and you get your a and b values. You get a equal 933.36 or 37 if you round it up. B equal 14,590.58. So this is your second step by using your graphing calculator. Third step, graph the model along with the data to verify that the model fits the data well. So you click on y, you enter y equal ax plus b. So you enter your a value, then times x plus the b value, and you click on a graph, and it's going to give you your linear graph function, and to verify that the model fits the data well. So a model for the data is y equal 933x plus 14,600. So hopefully in class I will do an example in my warm-up to show you how to do that in the calculator again. Example 2, cooling rates. You are storing leftover chili in a freezer. The table shows the chili's temperatures y in degrees Fahrenheit. After X minutes in the freezer, use a graphing calculator to find a model of the data. So you have your X values, you have your Y values. Take a couple minutes, if you can, plug it into your calculator and find the best fit model or what type of function is that. So please take a couple minutes to do this problem in your calculator. So now the solution for this example is step number 1, make a scatter plot. The points fall rapidly at first, then begin to level off. This suggests an exponential decay model. So as you can see, the points are falling rapidly at first, then begin to level off. So this is an exponential model, and it looks like a quadratic, but if you do second step and third step, you will see it's exponential. So use the exponential regression feature to find an equation of the model. So you will get y equal a times b to the power x, and that is your a value, which is 98.24, and b is 0.97. So step 3, graph the model along with the data to verify that the model fits the data well by entering your equation y equal 98.2 times 0.969 to the power x into the y feature, and then you graph it, and you will see and verify that the model fits the data well. Again, in example number 3, a study compared the speed x in miles per hour and the average fuel efficiency y in miles per gallon of cars. The results are shown in the table. Use a graphing calculator to find a model of the data. So please take a couple minutes again and read the problem and try to do it in your calculator. So now the solution, step 1, make a scatter plot. The points, so enter your values, enter L1 and L2, turn on your stats plot, fix your window, then graph it. You get this scatter plot. So the points form an inverted U shape. So the inverted U shape, this suggests a quadratic model. So use the quadratic regression feature to find an equation of the model. So if you click in linear regression, quadratic regression, you get y equal x squared plus bx plus c. You have your a, b, c values, and you just graph the model along with the data to verify that the model fits the data well by using the y feature. Enter the equation that you have, which is negative 0.00793x squared plus 0.727x plus 13.8. And if you graph it, you will get the U shape, with the inverted U shape, which is concaved up, and that is quadratic function. So our lesson target, we hit our lesson target for today, which is we use the graphing calculator to find the model equation for a given set of data, and I hope that helps. Thank you for listening and have a great day.